Welcome back to a new session. I'll be starting with friction. As you know, in my last session, we have done laws of motion, where I just show you the basic explanation for all the three laws, Newton's laws of motion, and along with that, we learned how to draw a free body diagram. We considered that all the planes are frictionless, it is smooth, but today we'll be learning about friction. Okay, so in friction, let us start the topic. Okay, so let me draw a plane as we have seen in my earlier videos. Okay, so if let's say this is a fixed plane and over which a body is lying. Let me say this body is body A, and as it is lying on the plane, so naturally there will be a contact force. The contact force need not always be perpendicular, it can act at an angle. So the contact force acts at an angle. Let's say this is my contact force F, because of Newton's third law. Okay, similar to that, there will be a contact force down also. The contact force up is because of from the earth to the body, and the contact force down is from the body to the earth. Okay. Now there will be a horizontal component of that contact force. If that angle is theta, the horizontal component is F cos theta, which we call as friction. So this is friction, and there will be a vertical component of that contact force F sine theta. That will be the normal reaction. So that we can also say that capital N. Okay, so let us try to draw the free body diagram. Okay, we'll just learn what is friction. So now, right now we have learned that if a body is just resting, if it is not moving, though we will understand, I have just listed down what are the topics we are going to discuss, like kinetic friction, static friction, laws of friction, illustration of that friction. Okay, here we are considering that the body is at rest. Okay, it is just trying to move, or it is, let's say it is totally at rest. Still there will be a component of the horizontal component, that is the horizontal component of the contact force, that we are defining it as friction. Okay, let me give another example. Okay, let us draw the free body diagram as we have seen in my earlier videos. Free body diagram. Okay, so if I say that there is a fixed surface like this, or I'll just draw it. Let's say this is a fixed surface, and there is a body A. Okay, and this is fixed. The body A is lying over it, and this surface is not smooth. This surface is rough. This surface is rough, and it is having a coefficient of friction. I'll just tell you what is coefficient of friction. That this friction, whatever we have learned here, this friction force is nothing but mu into N. Okay, where mu is the coefficient of friction, it depends on the material. Okay, and N is the normal reaction, and F is the friction force, unit in Newton. Okay, so here is this rough surface. So as it is rough, so mu will be there. Let's say it is acted upon by a horizontal force F, and as it is acted upon by a force, the body is accelerating with an acceleration A. Okay, let's say the mass of the body is MA, mass of the body. Okay, so if I draw what will be the free body diagram? How we learn to draw the free body diagram? In the free body diagram, if I just draw it separately, this body, what all we are going to get here? We are going to get, let us draw it separately. Let's say this is body A. So naturally MA will act down, MA into G, or let's say simply it is mg. So if I'm just marking at the body to be A, that is why MA into G. Okay, and it is acted upon by a force in this direction. There will be a normal reaction, that is N. Okay, since the body is accelerating towards right and it is having a velocity towards right, so the friction force acts opposite to the direction of motion. So the friction force acts in this direction. So that will be the direction of friction. Okay. In the free body, nothing else will be there. We have a normal reaction. We have mg down. We have the force in the right side, friction in the opposite side. So how do I write the equations? If it is accelerating with an acceleration, let's say it is a. So I must write the equation in the horizontal component as F minus F, that is the net force. We have learned that if the vector sum of the net force acting on the body is not 0, then the body is accelerating, is it not? So F minus F is not 0. So it is accelerating. What will be the acceleration? MA into A. Okay, and there will be, this is equation number 1. There will be another equation. We can write N minus MA into G is equal to 0, or M equal to MA into G. And this is equation number 2. Okay. From the free body diagram, we can write these two equations and we can find the unknowns. Okay. So you are seeing that direction, how friction is taken into account while we are writing the equation in the free body diagram, the force equations. Okay. Okay. What we can say that if I consider another body over this body, what will be the physics for that? Let's say another body is there, and let's say this was mu, the coefficient of friction between body A and the rough surface, and this was mu1, the coefficient of friction between, let's say this is body B and body A. How will you draw the free body diagram of body B? The body B is simply resting on body A. No force directly acts on it, but body A is pulled with a force in the right side. That is what is given. Okay, we have to draw the free body diagram of body B. How will I draw? Let me rub these things off. If I try to draw the free body diagram of body B alone, then this is my body B. This is body B. First, mg always acts down. Okay, so mb into g, it is always down. Okay, and the body B is also accelerating in the right side because it is just sitting over that, and we assume that the surface between B and A is not smooth, so friction coefficient exists. Okay, and the body B is not slipping. It is sitting steady. So who is preventing it from slipping? Of course, friction. So friction is preventing body B from slipping over body A, right? So now in which direction the friction force will act? So we can write that body B is also accelerating in the right side. So if it is tending to like there is a force acting on body A, then in which direction the force will act, the friction force will act in body B? I told that the friction force for body A will act in this side. So the friction force for body B will act in the front side, because the body B will have a tendency to go in the left side. If I consider the inertia, the body B was in a state of rest. Suddenly a force is applied on body A. The body B will have inertia in the left side. Friction will prevent it from slipping. So friction is acting in the front side for body B. Okay. So friction alone it is working. Okay. There is no other force. There will be a reaction force, obviously. Normal reaction will act. Let's say this is N1. Okay, N1 will act because that reaction body B will get from body A. Okay, so this will be the free body diagram for body B. Okay, if I simply draw the free body diagram, here we can write that F is not acting there, so we will write that only F should be equal to mb into A, because body, it is accelerating of course, and it is mb not ma, and only the friction force, the actual force is not directly acting, so only friction is acting, and of course n1 equal to mb into g. So these are the two force systems that we can write for body B. Okay, let me try to draw what will be the situation if it is on inclined plane. We have already seen inclined plane in the case of laws of motion. Here, how will I draw the for inclined plane? Let's say there is a body M over there. The angle is theta. Okay, and we know how to consider the local and global coordinate system. So if this is my global, that is x and y, so this will be my local, that is x dash, and we can draw one another y dash. So this will be my local coordinate system. Mg will act always down, and there will be a component of force. So if this is theta, then this is also theta. So there will be a component of force mg sine theta that will act down. There will be a component of force mg cos theta. What else? We will have a normal reaction that will act like this. We'll have a normal reaction. Let's say this is n. Okay, it is acting that in the inclined surface will act on the mass. Okay, normal reaction. Now if the body is slipping down the incline, there will be a friction force that is acting in the upside. So I should write a friction force F. Okay, I'll just enlarge the sketch little bit. Okay, so this is the friction force F. Now if I draw the force analysis, what I should write? Mg sine theta is down. So mg sine theta minus F. Friction is offering a resistance for the body to go down. Okay, so mg sine theta minus F should be equal to m into A. Okay, so that will be equation number 1 for the body that is tending to slip down, and we will have another equation that is plus n minus mg cos theta is equal to 0. So this is my equation number 2. So we will have two equations. There may be some unknowns. So we have to just solve it out. Okay. Now we'll just see some basic things like what are the kinetic friction and static friction. Some definitions we must know. So the first one is kinetic friction. Kinetic friction. I'll just write it for you. When two bodies in contact move with respect to each other, rubbing the surface, the friction between them is kinetic friction. Okay, so we can write kinetic friction is written as Fk, that is equal to mu k into n. Okay, the two bodies are moving, they are not static, they are moving and it is rubbing the surface. So in this case, the coefficient of friction will be called as coefficient of kinetic friction, mu k. Okay, and Fk is the friction force, n is the normal reaction, n will be mg. So the friction force will depend on, the friction force is depending on mu k, which in turn depends on the surface, okay, the material properties, and n. So n will be mg, so the friction force will also depend on mass. Okay, it is not directly, but since n is there, so n will be mg if the vertical components you just equate. So it will be depending on the mass also. Okay. Now static friction. Static friction, the bodies are not moving, not rubbing. Friction force, friction force can also act between two bodies which are in contact but are not sliding with respect to each other. Okay. Friction in this case, friction in this case is static friction. Friction in this case will be static friction. Now the maximum friction that a body can exert is called, on the other body, is called limiting friction. Let me just write it. Limiting friction. Let's say one object is there on the free surface, like let's say we have a body like this, and there is another body. If I tilt it down, is it slipping? No. Who is preventing it? The friction is preventing it, is it not? It is not slipping. So now it is trying to slip. Okay. Now up to the time the friction prevents the body from slipping, that will be the limiting friction. Let me write the definition for this. The maximum static friction, that a body can exert on the other body. Let me just, can exert on the other body, maximum it is written. Okay, maximum on the other body is called limiting friction. So what I should write here? F max, the maximum friction force. Okay, F max should be equal to mu s into n. Mu s, coefficient of static friction. So maximum friction force for the body to be held in that position. It is not slipping, it is not rubbing. The maximum force, the body is resting on it, you are just putting a force and it is not moving. Up to what maximum force you can apply. Okay, and the friction is just holding the body in contact. So that will be limiting friction. So limiting friction, we are not supposed to use mu k, we must use mu s. Okay. Now, there are some laws of friction, some basic laws. These are asked in your exams. Let us just read the laws. Okay, what are the laws of friction? So it is like, if the body if the bodies slip over each other, the force of friction is given by mu k equal to Fk equal to mu k into n, that we have just seen, the kinetic friction. That is number one, where n is the normal contact, mu k is the coefficient of kinetic friction, that we have seen. The direction of kinetic friction on a body is opposite to the velocity of this body. that we have seen some free body diagram. The direction of friction force is always opposite to the velocity of the body. Third one, if the bodies do not slip over each other, the force of friction is given by Fs is less than equal to mu s into n. Now it becomes limiting friction, then Fs becomes F max and the less than symbol will become equal to mu s into n. Now when it becomes equal to, then Fs becomes F max, that is equal to mu s into n. Okay, so that is the third one. And the fourth one is the friction force Fk or Fs. The kinetic friction or the static friction does not depend on the area of contact as long as the normal force n is same. Okay, these are the thing you must know. So what are the things we have covered? The laws of friction, limiting friction, static friction, kinetic friction. Okay, the free body diagram of a mass on an inclined plane. The inclined plane is not smooth, it is having a friction coefficient. Okay, in this case this F will be your mu into n. Okay, in this case. Then we have seen the basic body kept at rest. What will be the free body diagram? Okay, so kinetic friction, static friction, laws of friction, and illustration of friction in the inclined plane. Okay, so that's all for friction. We'll just come out with circular motion in my next video. Okay, circular motion, and then we'll start solving some problems. Okay, thanks for watching. Thank you so much.